Hello to everybody who is joining us already for this webinar. We're going to wait a minute or two until the participant numbers have stabilized. We can see how many people are dialing and as you are just arriving at the moment. So bear with us for a minute and then we'll get started. Okay, I can still see a few more people joining, but let's get started now to this webinar. It's a collaboration between Aiven and Thoughtworks. Thoughtworks is a global software consultancy, and Aiven is a managed service provider for open source data infrastructure. We'll talk a little bit more about those companies in the coming slides or during the presentation. But what we really do want to talk to you about in this webinar today is managing cloud carbon emissions, and I hope you will enjoy this. A few logistical things to start with. In the invitation, you saw Marco being invited. He would still love to come, but he works for ThoughtWorks and we are a consulting company. So he is actually working with a client today and can't make it. I've accepted to take over his part in this. And from a usability perspective, we are here, of course, to also listen to you, to answer your questions, to provide more detail. And we would ask you to please use the Q&A function. If you're not familiar with Zoom, you can find that at the bottom. It says Q&A. Please put your questions in there. We will use those. I will, towards the end of the webinar, go through this and take the questions and put them to our panelists. You can also use the chat function if you just want to communicate with each other or with us. If you want to give us feedback immediately, be mindful in the chat function, there are two different modes. The default is that you're only sending the messages to the hosts and panelists. So the other people in the webinar don't see your messages. Most of the time, people actually want the opposite. They want to comment on something and want everybody who is in the webinar to see it. So if you want to do that and use the chat function, please change that over to saying you want to send the message to everyone. But as I said, if you have questions that you want us to cover later, please do put it in the Q&A function. As a brief introduction, we have these four people on the call. I'm the CTO of ThoughtWorks Europe. I'm a technologist at heart. I've done quite a bit with sustainability, and that is also why I'm here today.
Cool. And my name is Eric Smith. I've been working at ThoughtWorks for the past 3 years. I've been working on our sustainability solutions team since its inception, and also have been developing and maintaining CCF since its open source launch back in March of 2021. So excited to be here.
Welcome on my behalf as well. So my name is Heikki Nousi and I'm CTO co-founder at Aiven, and also been working with Aiven's sustainability and social impact program for the past year, and working alongside with ThoughtWorks on something that we're happy to introduce a little bit later as well. Thank you.
Hi everyone, I'm Dimitri Kazvini. I'm VP Corporate Development and Sustainability Lead. We align strategy with sustainability. We've done that on purpose to be able to really bring sustainability into our strategy. I've been doing that at Aiven for the last 2 years, and today we'll share with you where we are at with our product and sustainability in mind.
Okay, and with this introduction over, this presentation or this webinar, the first part, the presentation is going to be in 3 increasingly longer segments. In the first one, I will very, very briefly give you a tiny bit of background before we then head to cloud carbon footprint, and then in the third and largest part of how cloud carbon footprint is helping Aiven achieve their sustainability goals. So, one thing that unites Aiven and ThoughtWorks, although we, of course, have a very different business model and different companies, is our commitment to decarbonizing our sector. What I'm going to mention on this slide here is slightly with the ThoughtWorks spin, with our perspective, but I think it is true for both of the companies. And as you've probably read by now, the ICT sector accounts for 1.5% of total global emissions, and actually even more for the electricity. We could put as many asterisks as you want on that statement because there are different figures here. This is here really just to give you a ballpark idea of saying this is a significant industry, and therefore, given that it is a significant industry, we should also make a significant effort to do our part in the reduction of carbon emissions. We, as ThoughtWorks and Aiven, are committed to actually collaborating with our peers, in the case of ThoughtWorks, with our clients, with policymakers. And the core part really is to drive innovative solutions that then in the end can reduce the footprint of our digital infrastructure. From a ThoughtWorks perspective, we can say that we have made available as open source software the Cloud Carbon Footprint tool that is based on the groundbreaking work that was done at Etsy, one of our clients, many years ago. ThoughtWorks is also a founding member of the Green Software Foundation, which describes itself as an organization that wants to build a trusted ecosystem of people, standards, tooling, and best practices for green software. And we are really proud to be a founding member and collaborating with them, or being a member that actually works on those goals. And as a consulting company, we obviously provide all sorts of transformation services, but also specifically transformation services in this field of sustainability. One thing that is important to remember is if you look at the carbon emissions, the Greenhouse Protocol talks about 3 different scopes. Our focus clearly here is scope 3, the indirect emissions from upstream and downstream. It is actually sensible to do it that way, but it is also harder to measure. And you can see I've highlighted this on the right-hand side of the slide. Scope 3 is really something that is quite out of the immediate scope of your organization. But if we think about the usage of computers, and especially cloud computing, we are not even buying the electricity to run the computers. We don't own the computers in cloud computing. So naturally, everything is in that scope 3. Scope 3 does have 15 subcategories if you look at it. I've highlighted 3 of them here so you can see the breadth of that. I mean, it's clearly the goods and services we do, the leased assets we have. I mean, there's all sorts of other things like business travel and employment commutes and so on. But I mean, what we really want to focus on is the sustainability of the IT solutions that we're running, and that we're running increasingly in the cloud. And then last but not least, just as a brief overview, there's a lot of text on the slide. I guess you will get the slides later and you can read the right side. It's the same thing. The diagram on the left-hand side is really what I hope you will remember. The framework we want to apply is that first, there is some learning and understanding of the whole domain. There are some ideas that are not immediately obvious, things that may appear obvious, may not turn out to be true. So there is really some upskilling, some learning of the fundamental concepts needed. The next step, and we'll go into much more detail later, is to measure and analyze the usage of the carbon emission, the usage of electricity, and to think about the carbon emissions then. We often say measure in many ways, and you will see this later in the presentation. It is also actually probably more of an estimation, but the idea is that you get something that you know where you stand, you draw a baseline, then you look at it from that baseline, you optimize and reduce, and then you can repeat that cycle, and hopefully in the middle, you get some benefits, and that would normally mean that you have a reduced carbon footprint. And in many cases, we're talking about the discipline of green ops here, is very similar to the discipline of FinOps, and oftentimes reducing the carbon footprint goes along with reducing the bill of the cloud providers and the money that you're spending. So there's actually that really proverbial win-win situation. That's really all I wanted to say as opening remarks. And I'm going to hand it over to Eric now to tell us more about cloud carbon footprint.
Yeah, just on this point, Eric, I think that's very interesting. This slide gives us an opportunity to introduce actually 3 use cases of the carbon footprint tool. Learn and understand, measure, analyze, optimize, and reduce. Those are 3 use cases. And for us, for Aiven, what attracted us a lot and created this partnership, I think, is optimize and reduce. Because effectively, what it does for you, this tool, it allows you to be active about your carbon emissions. And so this is something that I think we'll keep talking about through this presentation, but it's good to see those 3 elements as 3 use cases that each of our participants can use at different moments in time in their journey to sustainable cloud operations. But that's optimize and reduce. That's probably a bit of a uniqueness of your tool, and that's what we're going to talk about.
Eric, sorry, do you want to take over?
Yes, sorry, could not find my mute button. All right. So thanks for that, Eric. Yeah, so let's now talk about cloud carbon footprint. And as we kind of mentioned, if you're not familiar with it, it's the open source tool that ThoughtWorks has developed and that has launched back in March of 2021 for this exact purpose, to aid in decision making and help optimize and reduce your cloud carbon footprint and energy usage from cloud provider services. So just a little background of kind of how the tool works. It's architected to work for multiple cloud providers. So we currently support Google Cloud, AWS, Microsoft Azure, and are also currently in development adding support for Alibaba Cloud. And we also provide metrics for energy and carbon emissions for all types of cloud usage. So networking, compute resources, storage, you kind of name it. We kind of try to provide a holistic support for all of it. As well as we also provide actionable recommendations. So we provide a unified dashboard for viewing all of your right sizing recommendations directly from the cloud providers and try to attribute a carbon savings alongside those metrics as well as the energy savings. And you can also use it to monitor your usage and carbon footprint visually. So we try to provide a lot of at least healthy metrics with the dashboard out of the box to provide insights into your usage over time, as well as being able to see different breakdowns by services, regions, as well as other categories. And it is open and extensible, so our methodology is fully transparent. It is an open source tool that we're currently hosted on GitHub. Our methodology has been vetted by a lot of community experts, and we welcome and still encourage feedback to this day to hopefully make changes and continue to improve it. And this transparency was very important to us because kind of going into the next slide in a bit, this was kind of one of the reasons we developed the tool, which was it was hard to at the time to find a reliable and open way to gather carbon metrics and carbon calculations. And another, and I'll go into extensibility in a little bit, but one of those main examples is the way we've added on-premise through this extensibility, as well as electricity map support for marginal carbon intensity data, as well as other figures, which we'll dive into in a little bit. So I kind of mentioned there were challenges of tracking cloud usage. And I think kind of going into our joint solution in a bit with Aiven, they can resonate with some of these things. But one of the things that kind of led us to developing cloud carbon footprint was ThoughtWorks, of course, wanted a way to track its internal emissions as we were kind of seeing not only for our clients, but for ourselves, a growing usage of cloud services to kind of support this growing landscape of software. And one of the major things that came up that existed during that time and still even kind of today is that there was an inconsistent way of measuring carbon footprint across the different methodologies for the different cloud providers. So at the time that CCF was developed, there wasn't any tools out by the cloud providers, but even now to this day, they exist, which is awesome, but they all still do things a little bit differently. And so one thing CCF does is that we kind of provide a unified methodology across all of the different cloud providers, which again, if you're talking about optimizing and reducing for a lot of multi-cloud organizations, this provides you with a more apples to apples comparison to do so and to kind of see where you stand across your entire infrastructure. There was also limited data available from cloud provider services. So a lot of the data resources you'll find that we use for CCF are kind of publicly available data sources such as spec power for energy data for different machine configurations, as well as electricity maps for carbon intensity data, and whatever we could find from Google Cloud, AWS, and Azure in terms of power usage effectiveness for data centers and other published data. And there was also an issue with the frequency of publicly available data that is updated. And so one thing about CCF is that we source, and I'll go into our methodology in a bit, but we source usage data from cloud provider billing data. So this allows us to not only have a configurable granularity of daily, monthly, quarterly, yearly, or whatever makes the most sense for your organization, but also we can provide estimates as frequently as the billing data is updated, which usually is multiple times a day, or at least a more completed data set of daily. And so one of the main, Eric kind of spoke to kind of incorporating sustainability to driving decision making with that kind of model that we saw on the other slides. And this was kind of the thing that we wanted to focus on as well, which was kind of starting at the practitioner level, but creating a tool that enables every level above it. So one thing, of course, we wanted to create a tool that was open and configurable for software developers to incorporate sustainability as a cross-functional requirement. So we mentioned that you're able to gather estimates as granular as daily and as frequent as the same day, if not the previous day. And that was kind of the main motivation behind it, which was really closing that feedback loop to where if I'm launching resources on my cloud provider, I can be able to at least see, if not the same day, then the next day, what my footprint is and what my impact is. And of course, Eric mentioned there's some green ops aspect to it, and a lot of that motivation went into CCF as well through financial management and driving value-based investments and cost optimizations. We try to empower infrastructure leads that want to make optimizations over time, which is why we kind of support the quarterly and larger grouping of yearly to kind of get a more holistic view, if not a more granular day-to-day view. And then, of course, allowing and enabling the executive vision through overall goals and targets to hopefully allow a tool that allows you to gather data to help you not only drive towards results for your sustainability strategy, but also if you're not quite there yet in creating one, to allow you to see where you stand, to hunker down and get a better picture of that. And this is just a more breakdown of user personas. I won't dive into this too deep, but again, enabling software developers that want to understand the impact of their application of code they're writing, infrastructure leaders that want to understand, prioritize, and manage impactful optimization opportunities. So kind of going into our recommendations dashboard and the fact that you can view multiple sub-accounts within CCF through that connected billing data source. And of course, also enabling sustainability leaders and finance operations as well. But let's get into the fun part, which is how do we build this thing? So we kind of tried to give a domain-driven and modular approach. So you'll see within our GitHub repository, we're a mono repo of multiple packages. And if you're not familiar with these, it can be quite overwhelming. But the TLDR of it is that there are 3 entry points or ways that you can use CCF, which is through interacting with the CLI, the API, or through the dashboard that we make available. And from there, we have another package, which is our app that kind of distributes requests to the specific cloud provider that you have configured. So a typical setup, it would look like you would, and you can view this on our Getting Started page on our website, so I won't dive too deep into this, but you would typically configure through environment variables or configuration variables, the cloud provider information for the account you want to connect. From there, you would make a request for a specific start and end date. And from that request, our app will distribute or gather usage data from the different cloud provider through that configured billing data table. So for AWS, think your cost and usage reports. For Google Cloud, think your billing export table through BigQuery. For Microsoft Azure, think your cost management API or usage details API. And then from there, we turn that usage data, map the usage type to its appropriate machine configuration. So if it's a compute resource, we look at the processor family and the configured memory and virtual CPU cores. And then from there, using the spec power data that we have configured, we're able to get a energy utilization from or energy usage from max utilization and idle, and take an average of 50% of that to convert into energy usage. And then from energy, we're able to use the carbon intensity data for a specific region to convert into CO2 in terms of metric tons. So from there, that's when you would typically get the energy data as well as the CO2 for the different services that you have under your account. And so this is the default dashboard that we kind of spoke about. You're able to view different metrics from your CO2 kilowatt hours of cost over time to your cumulative emissions in terms of total metric tons of CO2 for your entire, for all of your accounts. Carbon equivalencies to help humanize the numbers that we're seeing. So in terms of direct one-way flights from NYC to London. And we also have a carbon intensity map so you can kind of see what the different carbon intensity is for data centers across different regions around the world, as well as the unified recommendations dashboard that I mentioned, and a forecast that can kind of give you an idea of what your last 30-day total was in terms of emissions and what your projected 30-day total is for the next 30 days if you were to take the most optimal recommendations. And we mentioned some differentiators here. I won't dive too deep into these, but of course we have our data sources, which is, again, being able to configure electricity maps for real-time and historical marginal emissions. We try to take an unopinionated approach in some areas where it makes sense, because things such as incorporating carbon-free energy percentages, we've noticed that some users may want to opt into or may want to opt out of. So we try to allow configuration for that, such as being able to disable or enable carbon-free energy percentages. Same thing for having a consolidated right sizing and idle recommendations dashboard, but also for we support on-premise, which we like to think is a pretty big differentiator, which is that we have early support for using our same methodology to estimate on-premise usage for servers, laptops, and desktops, which has been really great as well. And we allow different customization options so you can kind of configure your own machine coefficients, provide exact CPU utilizations, as well as allowing accuracy with data availability. And again, it's all community driven and flexible. And one thing I want to point out is that CCF is self-hosted. So we're not a kind of out of the box or a SaaS product. It is, if you were to think of something like Spotify's Backstage tool that you would clone or create an instance of and deploy within your own infrastructure. And so there's flexible ways to use it. I mentioned that you could use a CLI tool for a direct CSV input, or even view your emissions directly within a terminal. We mentioned our dashboard, which has our API behind it. You can also interact with our API directly to configure a custom dashboard, which we see in the top right, which is an example of using the exported CCF data from our API to view emissions over time within a visualization tool such as Looker Studio. And then within the bottom right, of course, you can see there are direct ways you can query your API and maybe integrate it into your own dashboard or tooling as well. And I mentioned we've had some integrations before and customizations. One of the coolest things that have come out of it is we have a Backstage plugin for CCF, in which you can configure CCF and have an integrated dashboard within your Backstage instance. I mentioned that we partner with electricity maps to allow you to provide your subscription and be able to use electricity maps, carbon intensity data for real-time emissions, as well as accurate historical emissions. We've also recently announced a collaboration with OpenCost to allow for carbon and energy data to be viewed within your OpenCost dashboard. And I think that's what brings us here, which is this extensibility and customization has been at the forefront of how we wanted CCF to be developed, to kind of meet you where you are in your sustainability goals and get carbon data in front of customers in the best way possible. So I will actually hand it over to our folks at Aiven to talk about how they developed a new solution using CCF's methodology.
Thanks, Eric. That is a very good introduction to our slides. And what I will talk about a little bit is about our journey, how we ended up partnering with Thoughtworks about the tool, and then what does our tool do effectively. And I think I will start by, we started with the customer in mind, and some of our largest customers requested a tool for better emission calculations for their multi-cloud setup. So we started with those customers, retail companies, energy companies, that really were using our platform in a multi-cloud environment and wanted to get a better handle of what happens there, what level of emission their infrastructure produces. And so the first use case we wanted to address was the reporting. You remember those 3 use cases that Eric mentioned at the beginning. And so the reporting is one of them. You measure, you report. But then we very quickly realized that we can't do more, because we can do more because actually what we hold the customer data either in our data stores, our databases, or in event streaming, in streaming data. So it all transitions on multiple clouds through our platform. It's either data at rest or data at movement. So actually we said we could, first of all, individualize projects, not do the reporting for the whole organization, what is the kind of their overall cloud infrastructure usage and emissions, but we could look at project by project because we were the people who host those projects. We have the information in terms of usage, memory, compute, storage, so we could do something about it on a project by project level. And then for the same reason, we could do something even more granular than Eric was referring to daily data. Well, actually, because we see those things happening at the moment when they happen, when the data transitions, where it lands, when it uses all that infrastructure, we could find a tool that connects to our infrastructure sort of monitoring tools and get the actual usage. So we went on a journey for that, and we found ThoughtWorks tool that was open source, and it was great for us because open source is what we're about. All our data stores and products are open source. And so Heikki in a second is going to talk a little bit more about specifically how we implemented it and what it is. But what I wanted to leave you here with as an idea is really we kind of, just like Eric was showing before, the user personas for us, what we wanted to get the sustainability teams to collaborate with the developers and the DevOps in their organizations. Because what we realized is that a lot of our own developers and our own DevOps are sort of driven by values. They are active people that have active positions on societal questions. And so environment sustainability is one of them. So they were pushing us to do more. And so we saw that same thing happening in many companies. And a lot of them are asking, what is the company doing? What is my company doing for my planet? But very quickly, sometimes they move, and very often actually, they move into, I wish I could contribute with my work to that sustainability effort. So we thought, wow, that would be a great thing to be able to give them a tool where they can start working with the sustainability goal in mind. And then from the sustainability teams, one of the big questions is always, how can I engage more with my colleagues on the sustainability journey? How I can be part of my corporate fabric, my sort of not to be isolated somewhere in one function, but really outreach to other people, and especially to my IT org, and do something together with them. So that sort of sets the scene of where we started and why, and then I will hand it over to Heikki to talk specifically about what we have done.
Yes, here we go. So indeed, we at Aiven, we share a lot, very much about what was talked by Eric and Arik earlier on the importance on getting that visibility into emissions as a first step to really to understand and provide that information in a detailed level where it becomes actionable. with the long-term goal, of course, being in how we can together optimize our workloads and ensure that we are reducing those emissions arising. And as mentioned, Aiven is a managed service provider for data infrastructure. So we use a lot of cloud resources to implement the services that our customers utilize. 50% of Aiven emissions arise from cloud usage that is directly linked to our customer workloads. So I think we're very much alignment in or hoping to help our own customers for their own reporting and optimization needs, but we also then kind of want to see our customers actively succeed with those reductions of optimization efforts to also lower the Aiven emission profile as well. So we're much aligned on this one, this with our customers as well, and being a great project to work in that context. But to kind of when we started to look on how could we provide that insight and that reporting information to the developers, to our maybe the FinOps people in organizations, we were facing the very same challenges as Eric mentioned for CCF. So the reporting between the cloud service providers, if any, we are working with 9 cloud providers altogether. Some are more mature in this field than others, but still pretty much all the cloud providers, they count their emissions a little bit differently. So it's really hard to make comparisons and then make those optimization decisions on where and how to run those workloads without having that apples to apples insight. When we are looking at the data provided by the cloud providers, it usually lacked the level of granularity that we needed to be able to really show on what is the impact of a single customer service, what is the impact of a single streaming cluster that the customer is using, to be able to account those and attribute those emissions into a single service, so that we could again look at the different services that we have running and then do perhaps optimization on those. And likewise, we were looking at the cloud provider reports, the granularity in the temporal zone or time zone is that usually you get a report on the emissions on a monthly basis, aggregated on the level of 1 month. And in some cases, it's also delayed until it's calculated for a month or so. So it's really hard in this context to run, say, experiments, looking at those optimization opportunities, and then verify the results, how those experiments pan out. So this was our starting point. We started to look, and we very quickly came to cloud carbon transparency into the methodology on how these emissions were calculated, and having that insight into being able to compare workloads from different cloud providers to one another. So that was kind of, for us, resonates with our open source foundation and mission, and this was something that we took as a starting point then to provide our customers with the information on what is the emission impact of running actual Aiven services. We still have a little bit of challenges because the way we operate, we run on behalf of our customers, we run somewhere between 125 to 150,000 virtual machines at any given time across 9 different cloud providers and across all the regions supported by those providers. So when we are looking at cloud carbon footprint, while we could use it, still relying on the cloud provider consumption or billing information wouldn't give us the right level of granularity on being able to attribute these emissions to specific services. But we loved the methodology. It looked sound to us, and we certainly weren't experts in this field. So having a methodology that has been vetted by externals helped us to build perhaps on top of the cloud carbon footprint tooling. At Aiven, we do count and account for all the resources that actually go into implementing our customer services. So we took the methodology and the CCF, our cloud carbon footprint, say coefficients or coefficient numbers, meaning on say what is the energy uses for running a specific type of CPU, and then we approach it from the resource utilization record standpoint and how then to move from that towards the calculations. So it's essentially the same, or it's a re-implementation of the cloud carbon footprint, but coming from a kind of set of distinct resources that we can, or a list of resources, utilization records on resources that we've done to then to drive those customers. Or drive those calculations, sorry. And this gives then us the power to actually go and go drill into one service level or project or collection of services, or even organization level collection of multiple projects. It allows us to take a time spans from down to 1 hour to a day to a week, whatever it makes sense, then to gain the best insight out of that data. And we really want to enable then our customers, both with the reporting information, but also with those opportunities to really run experiments on this data, and then, or experiments on adjusting settings on a service, maybe sizing of that service, and then verifying what is the impact on not only for cost, but also for the emissions generated. This also allows us to do projections for the customers, so help our customers to select perhaps the most efficient data center that serves their own customer base with well. So we're looking at Europe, for example, even within one single provider, we get very different emission profiles because of perhaps how new the data centers, how efficient they are, and then the energy mix used in the locality where that data center is established. So this is our hope, that is one part of us being able then to start really helping the customers on optimizing and reducing their footprint. Yes. So here we have published this implementation or Python port of the our tool, which is fully built on top of the cloud carbon footprint, and we echo the same. We believe strongly that these calculations need to be in open source so that they can be validated by external parties, validated by the cloud providers. We hope that this tool, now it's used internally for Aiven, but we hope that it is then useful for others working on calculating their own emission profiles, whether it's in a different cloud or whether it's on-prem, and kind of contribute in that fashion. We are hoping then to bring our partners, the cloud providers, jointly to validate and verify the numbers in cloud carbon footprint tooling and the Aiven tooling. We're using the same underlying numbers for those calculations. And then we are hoping then to just build a community around the cloud carbon footprint and the tooling, to really have tools in the hands of commons that or for a common good that can be used to estimate these emissions and really optimize your own workloads to make sure that impact on the environment is minimized in the longer run. As for Aiven, so that tool is open source, kind of continues to be developed further. We certainly want to continue on making sure that we do the accurate comparisons. So that is, but as an integrated solution, we have now. See, Yeah, here we go. So we have integrated this tool into our own API, or sorry, our own console. All the data is available through API as well, and we are looking forward to implement ways to expose this information, whatever it is, whatever it is easiest to consume for the organizations wanting to utilize this data. But here isn't just an example view, one single project and the kind of monthly trend on how the emissions are developing over the months. So this is one way of our exposing. We're looking at ways on how we could make this data even more apparent, how we could find or make sure that the developers, when they are looking on the performance of their services and perhaps planning for the next ones, they would have this information at hand. Make sure that when developers are selecting perhaps operating locations, they take the emission profiles into account as well. This is our first step. We believe that this is a journey, so definitely will be interesting to work forward in also creating kind of a trusted advisor, looking at workloads when we have this view across typical and multiple workloads from different customers, different use cases, figure out what's the common parts of this and looking at ways on actively reducing that emission impact, or perhaps even recommending that different operating location for the better say performance to emissions impact. And then lastly, but not least, we're really hoping that we can find that community that could benefit also from the exposure of our say the cloud footprint and how we run in other places. If we can help the community to build more accurate models on calculating these, or even better, if we can find jointly ways to reduce the overall emission impact, we'd be happy to share insights into all the data that we collect. And with that, maybe it's back to Dimitri.
Yes, trying to, yeah. And, oh, sorry, yeah. One last point that I wanted to mention is that, as you've seen, we talked about those use cases. We started by talking about our journey, which was measuring and reporting. Then we went to optimize and reduce. But there is a third use case there that that this tool can be used with in mind, and it's monitoring, as mentioned at the beginning. And monitoring is interesting because it allows you to experiment, but it allows you also to look at the new technologies and see what impact do they have on the level of emissions of what you do in the cloud. And here, just a little kind of opening to something that is quite topical today is Gen AI. And we are running a lot of discovery calls in the business side of things about Gen AI, understanding what our customers want, what they do with Gen AI, how they perceive the Gen AI. What we see actually is very interesting, even from emissions perspective. What we see is that there are patterns that would indicate that Gen AI, at least as of now, requires more consumption of cloud resources. To drill down a little bit more on specifics very quickly, is that we see a lot of customers saying that they need to retrain their models because there is a drift, because there is new information that is coming, and they want their kind of models not hallucinating, their models being current on the information they provided customers. And we picked up that specifically with the customers that work on client-facing chatbots. We see that there is also some need to make changes to the prompt layer and then retrain the models again, because the providers of LLMs do changes with the new versions of models. They do changes in the way they function. And so they require retraining. All of that puts additional requirements on the resources. And then one of the customers commented and said that we're now storing everything, that much more data now than before. So all of that indicates to us that this tool can also be used in those new technologies when you set up their sort of the infrastructure for those, be it in vector databases, being in be it in model runtime. You can see what happens there, and you can monitor, you can kind of take handle on those. And so this is where I think those three use cases come together for your existing workloads and for the future workloads that you want to build. And this is how you can use this tool in those different situations. That's all for me.
Okay, then we have about 15 minutes left. Thank you, everyone. I think for sticking to the time and for giving a really concise overview of the field. We have 3 questions in the Q&A at the moment. I'm going to start them from the top. I think we can answer them live. The first question comes from Zach Moore, and he's asking, are you familiar with the G+ strategic organizing framework? That question was asked relatively early on in the presentation. I personally will say I'm not familiar with the framework, but I'm looking at the round. I don't know, Dimitri, Heike, Eric, you've heard about this? Is that relevant from your perspective?
I'm sure it's relevant. I just don't know what it refers to. Is it G+ for Google? If maybe Zach can tweet a little bit more and make his question more, sort of unpack his question.
Okay. Yeah, I did check while I was listening to you on the web, and I couldn't, because I also assumed at first it was a Google thing that I hadn't heard about, but I couldn't find a trace of it in the Google context. So yeah, maybe Zach, if you are still on the call, you can maybe re-ask the question with a bit more context, and we're happy to return to it. The next question, I guess, Heike, you are the person who is probably going to be able to talk about it the most, is what are your tips to track customer usage data? Because you said that was a key thing really in the implementation that you did. I mean, I could easily say, of course, if you're in the cloud, always tag the resources you're creating so you know who's using what electricity, what resources, and so on. But I guess you have a bit more to say about that than I.
Yes, this question, I think this came during Eric's presentation, but I can take a stab at or take our point on this. So indeed, this is the one of the challenges is that although the cloud providers are fast moving in improving on this, but the tagging support is not always reflected in the emission reporting. The granularity is certainly one of the challenges why we were looking also first at cloud carbon footprint, and then we're looking was the reason why we went on implementing our port of CCF tool. But yes, in general, tracking or tagging resources, making sure that we can attribute them to specific services, even better if we can start to attribute some of that usage to actual, say, users of those systems.
I agree. And definitely a +1 for tagging. If you have any type of proper governance or organization in place over your resources, it makes tracking easier. Even CCF has tagging support at the API level, so you can be able to filter based on tags. You'll have resources or estimates. The tagging for resources exposed as part of the estimation results, so you can be able to aggregate or track accordingly. So if you have something, if not tagging or similar to tagging in place that allows you to be able to properly attribute specific buckets of usage to a customer, that'll be the key thing. And definitely don't want to overplay. It's not easy, but that's why the earlier you incorporate it, the better it'll work out in the long run.
Okay, now there's a number of questions that talk about the environments in which CCF can be deployed. So maybe Eric, mostly for you. So the first question comes from Robin, and he asks, are there any plans to integrate cloud carbon footprint with the Oracle cloud infrastructure? Or could this be done by the community? Could it be added in another way?
Yeah. For sure. So as far as officially, at least from a maintainer's perspective, there's no official plans, but we welcome it and encourage it. So just to kind of paint the perspective, Alibaba Cloud actually was developed by other thought workers, but mainly from a community perspective because it wasn't the CCF team per se. But it was thought workers who had a client interest and they said, hey, we want them to use CCF. It'll be really cool if we can add Alibaba Cloud support. And we were able to support them in that to give them what they need, provide technical oversight, all of that fun stuff. So we would encourage the same thing for Oracle Cloud. The challenge about it is that, especially now, we only have insights into our own usage. And whether I'm speaking for myself or for ThoughtWorks, we only use so many cloud providers and have so much usage, especially as a consultancy. So things for the three major cloud providers were easier because we have a footprint in all of those, or at least direct clients that use it that would allow us to experiment in that way. But for Oracle and Alibaba Cloud, our exposure is a bit limited. So if you have interest, please open an issue on our GitHub repository. Myself and our other maintainers are open and excited to help you see it through. But that's where we kind of lean on the community because you would be the one that has the exposure to the usage data, the billing, the Oracle Cloud resources that would allow the implementation to be done.
If I can add a little bit on that one. So that's Aiven has just launched Oracle Cloud support as well. So I think it would be in our interest to support that work on getting those numbers as well. And this has been really also part of the strength of our relationship with ThoughtWorks on having the experts available to also extend the region coverage or CPU architecture coverage to something that maybe we see in the field through our customers as well. So having those experts available on making sure that we can extend the open source implementation as well.
That's great news. And then taking it one step further, Gunther Schichtel is asking, I think if I transcribe the question, can you make CCF available for on-prem? I mean, for me, it's interesting because I know originally Etsy was driven towards the estimators because they were going from on-prem to the cloud. On-prem, as far as I'm aware, they were actually measuring the data because it was the data center that they controlled, right? And they started doing these estimations going into a public cloud. Is there anything that stops an organization from deploying cloud carbon footprint on their on-prem hardware?
I don't think there is. So hopefully, so I may have misinterpreted that question. I thought it was asking about estimating on-premise machines, but I can answer both just in case. So as far as support for estimating on-premise infrastructure, we have that. It is kind of very early and we welcome feedback on it and hope to build it out into a full dashboard and additional features. Right now, it's you plug in like a CSV input and then we export a CSV output of the emissions for all the resources and line items you provided. So that is there, and we encourage you to check out our website and kind of read through the methodology and how we do that. As far as deploying on on-premise servers, you should be able to. We have a nice blog that I actually wrote about how to deploy CCF on a virtual machine. It does speak to AWS, but if you have any other virtual machine or similar on-premise or way of interacting with a machine through your on-premise servers, you can deploy CCF within the same way. Of course, configuration and networking things and security and all that will vary close to your environment, but the short answer is yes.
Great. So for the panelists, Zach has come back and there's a bit of a link. So maybe if you want to have a look at that, I'm going to go to the other open question that is still remaining. And Tom has made a comment on saying that the FinOps Foundation has a focus project to push the cloud service providers to align on data structures so that you could get probably the same usage billing data and so on. Are you aware whether there's any effort underway to actually do the similar or the same thing for usage as it pertains to carbon emissions? I mean, I can personally say that from what I've seen, the numbers point in the same direction, but because there's a lot of estimates and the estimates are sometimes multiplied, they are not exactly the same. I mean, one very obvious example was I looked at the data for Stable Diffusion, which is one of the large Gen AI image generation models. And in the paper on Hugging Faces, they say that the calculation of the model was responsible for the emission of about 11 tons of CO2. Then I used a tool that is available on the web, an open source tool that estimates the power usage of graphics cards. And that estimated with the same region. I used the same type of graphic card, the same cloud region, and the tool estimated about 13 tons of CO2 emissions. So you can see 11 tons, 13 tons, there's a difference, but directionally it seemed relatively okay. But is there a kind of standard? Are you aware of it? I'm personally not.
Yeah, I'm personally not aware of it or familiar with it. I have heard a little bit about it. Another maintainer on our team is heavily involved with the FinOps Foundation, and I wish he was here to kind of speak to it. So if you kind of want the CCF team perspective, feel free to go to our GitHub or drop a email in our Google group, and one of us can get back to you on it. But the idea of it sounds cool. As again, someone who works on CCF with our goal of kind of providing a holistic view of carbon data across the different cloud providers, having a standardized cost format would be awesome for us. You probably see that I mentioned like we have like the AWS package and Google Cloud package and all of these packages for the different cloud providers, and their job is to standardize kind of the billing, to fetch the usage data, standardize the billing data in a way that it's kind of a usage format that CCF can recognize and estimate. So if we were to have something like that, that would definitely help with that logic and reduce the complexity for adding additional cloud providers such as Oracle and Alibaba Cloud. Because again, that's the biggest job, which is when we talk about adding Oracle Cloud, we don't know what their billing data source looks like and what that looks like for a customer and how we can be able to parse it to get compute, networking, storage, and all the different service usage that we would need. So if we did have that, then plug and play would be as easy as just adding Oracle Cloud instead of let's find out what their data set looks like.
Okay, and then maybe for the last few minutes, if the link that Zach sent on the G+ framework, did that jog anybody's memory? Does it make more sense? Does it look like you've seen it? Or is it a good hint for us to all just look at it?
Sorry, I was just checking it out.
Sorry.
My link don't want to open in a timely manner. It looks interesting. I'm personally still unfamiliar with it, but I'm happy to check it out and look into it. I appreciate you bringing it up.
Okay, thank you. So we are out of time and out of questions. What a perfect coincidence. So thank you all for being great presenters, for explaining this complicated subject matter in good to understand terms, I think. And thank you all for listening, for staying with us. I saw that basically nobody left during the actual presentation. So that's also a sign that you folks in the audience, you appreciate the content. So that's good to hear. And thank you for joining us today.
Thanks.
Thank you.
Thanks for giving us this opportunity to talk together about an important subject for all of us.
Yes, thanks everyone.